Now let's look at another application of recursive formulas. Let's say you get an inheritance of $91,795. You want to invest it at 5% yearly interest compounded monthly. Compounded monthly means a little bit of the 5% is added each month. In other words, 1/12 of 5% is added each month. Or I shouldn't say added, but you get that interest rate each month. Each month you deposit an additional $400 to the account. How much do you have at the end of 10 years? Since we're compounding monthly and we're adding monthly to the account, that 10 years needs to be broken into months. So we're going to say that's at the end of 120 months. So that's what we're going to be looking at as far as our time period. So think about what's happening each month. So I'm starting with $91,795. So I'm going to call that my A sub 0 or whatever. Actually, I'll just call it A sub 1 for the sake of my spreadsheet here. Then the second month, so on the second month, then I would be taking that $91,795 and 91,795. Then I'm not going to number them right now. Then I'm going to take 91,795, add $400 to it. And then I'm going to add interest. Okay, well, how much interest am I going to add? I'm going to add 1/12 of 5%. So I'm going to multiply 1/12 of 5% times this total amount. 917. Having trouble writing this number. 917.95 plus 400. Then I would figure out what that number is, so that is going to give me how much I have at the end of that month. And I would take that number, that new number, so whatever my answer is, I would take my answer plus 400, and then I would add the interest, which would be 1/12 of 5% times that answer plus 400. So the answer plus 400, the previous amount that I had, adding 400. Now this could be simplified down a little bit to, since this is 1 times the answer plus 400, and this is 0.05 over 12 times the answer plus 400, this would be 1 plus 0.05 over 12 times the answer plus 400. Now, I could get a decimal number for this, but since it is not an exact decimal, it'd be a repeating decimal, I'm going to leave it in fraction form to have a more exact answer here. Now, on my calculator, then I would start with this being my initial amount. I would put in 91795, push enter, then I would type in this and just keep pushing enter until I got through 120 months. But let's look at how this works on a spreadsheet. So I'm going to open up a Google spreadsheet. Okay, this is a Google sheet. So if you go into Google Drive and then you go to new file, so I did this over here, go to new, and then open up a Google sheet. So that's what I did. So in a spreadsheet, I'm going to put in my initial amount here, 91795. Now the way recursion works in a spreadsheet is that I'm going to refer back to a previous cell in the spreadsheet. So this is cell A1. So if I type in equal here when I'm in cell A2, then I can say that month 2 is going to be 1 plus the 0.05 divided by 12, then times, and you use a little asterisk, usually above the 8 on your keyboard, the asterisk for the times, and then A sub 1, or sorry, A1, cell A1, and notice cell A1 is referring me back then to the previous number that I had, plus 400. Okay, so there's the A1. Notice it's in orange and this is in orange. That's the number that A1 is, plus 400. And close the parentheses and push enter. Okay, so this number right here, clicking on this, is the previous term, A1, plus 400 times the interest, 1 plus 0.05 over 12. Now, if I drag this little cube down here a couple more times, I notice I get some different numbers. So look what happens in cell 3. It's referring back to cell 2. it's saying take whatever's in cell 2, add 400, and then do the interest. Then here it's saying the A4 is referring back to cell A3. So this is, by just dragging down this box, it is creating recursion. So I want to go down 120 months. Well, since my initial amount was in month 1, I'm going to go down to A121 because that would be 120 months of the process. So going down to 121, this tells me then at the end of 121 months, or 120 months, because that's the first plus 120, that gives me the 121. This is how much money I have total, $213,558.95. Now let's say I wanted to know of that total amount that I have in the after 120 months, how much of that is interest and how much of it is money that I actually deposited into the account. So I'm going to start by just saying this is equal to equal to A121. And that picks up that number there at the bottom. That is my total. So there's my total. Then I want to know how much money I actually put into the account myself. So the amount of money I actually put into my account myself is equal to A1, okay, that 91795, plus 120 deposits of 400. So 120 plus 400. So this is the amount of money I deposited myself into my account. The difference between this is the amount the bank put in interest. So this is equal to, and then I'm going to go up and get cell C1. So you can see if I just go up and highlight it, it types it in for me, minus, and then I want cell C2. There's C2, and there's the amount. So $73,000 of this total, $73,763.95 is interest that the bank has added to my account just for me putting in my deposits. $139,795 is money that I deposited myself. Now what's really cool about this is if I don't change the interest rate or the monthly addition of $400, let's say, what if I only started out with $1,000 instead of $91,795, and each month I saved $400 and I had this interest rate. So if I just change this to 100 and push enter, everything changes. So this now tells me that I would end up with $62,536.42 at the end of 10 years. $48,100 of which I deposited, $14,436.42 of interest. So starting out, well, that started out with 100. I meant to put 1,000 in there. So this is actually just starting out with 100 and adding 400 every month. So what if I started out with 0 and added every month? So I can just go ahead and change that because this automatically picks up the previous amount. If I go back and edit the formula and change the interest rate or the amount I'm adding every month, I could do that, but I would also have to fill down again to recopy that formula over all of these cells. So this is how you use a spreadsheet. Going back, let's just fill this in, the information of what I did, so that you have a record of this. So in cell A1, I put my initial amount. In cell A2, I put equals, and then I would put my interest. So this is the amount plus the interest. And then, oh yeah, I need to put my little times. That's important that you put the asterisk in there, or it will say error. And then I would have A1 plus 400. So what happens then when you see A3, it'll copy it. So then when you got this little square right here, and you're going to drag it down. Drag down. And when you do that, you find out that this becomes 1 plus 0.05, 12, and then this little asterisk, and this becomes A2 plus 400. Okay, so dragging down makes that automatically happen. And you got down to A121, and that was the total after 120 months. Then I wanted to know how much of this was interest. So I took my total and I made this equal A121. So that was my total. Let's see here. This was C1. C1 made that equal to A121. It recopied my total. This was my amount that I deposited. Amount deposited. I said C2 is equal to A1, that's my original amount, plus 120 deposits of 400. So 120 times 400. And then C3 was C1 minus C2, and that was the total amount of interest that I got on the account, because take the total minus anything I deposited, and that would give me the amount of interest that I got on the account. So being able to use simple algebraic rules, a recursive process and a recursive formula is really useful for working with spreadsheets, and a very valuable skill in the business world.